Dear students, if you remember that I have discussed in much more detailed way how to write a good scientific research paper in the last session. Today, I just want to share one of the example that when the students complete their research work, especially the thesis, either it's BS or MPhil, or even sometimes for the PhD. So in the very few articles, they do some mistakes. So I just one of the students have presented me her first paper on one of the research which she has recently completed for her thesis work. So let's find out what's the good in that manuscript is and what can be improved. So let's start one by one. So the first, let's have a look on the title, novel existence of agido-BIOCL nanostructures for promising photocatalytic activity against MO dye. So in this title, I would suggest that whenever we are using the abbreviations like BIOCL, I should write that bismuth oxychloride nanostructure. That would be a good thing to move on or to add. And another very interesting things which you can actually get away from, that the word using against. So let's use more positive words, or you can rephrase in a way that it looks more attractive, or it would have a very positive impact. And then even for amodi methyl blue, you can use the complete name instead, amodi. And even when we are using the novel existence, so as long as your work is so extraordinary, then use the word novel. Otherwise, you can get away from, right? So I would say that the title of this paper could be that cost-effective synthesis of agidope bismuth oxychloride nanostructures for their applications as for their photocatalytic application for degradation of methyl orange dye, or even you can use the title like the synthesis of agidope uh, bismuth oxychloride nanostructures for their applications as an efficient photocatalyst. So in that way, you would have a liberty to add even the photocatalysis and even the mechanism, or even the allied application. Even you can add that. So your title, that sometime that definitely needs some more attention to work with, right? And then let's have a look. If you remember, in the last session, I have discussed that the abstract must have the three things: what you have done, what are your results, and the third is interpretation. Have if I have a look on the abstract, so obviously it's a good, but the few suggestions with reference to the last session, which I've conducted in a much more detailed way. So yes, I can see what has been done, that is explained well. That's absolutely fine, and even I can see some of the result. So that's the good thing to move on. And one thing which I am missing over here is that I couldn't see the interpretation. So, for example, even in the last maybe part of this abstract is remarkably a 7% agido BiOCl catalyst with degradation efficiency of 89 in 120-minute exhibits the most efficient outcomes. Now over here, then there must be some interpretation that why it's the best. But maybe the band gap had played a role. Maybe that is the good focusing of the light could have contributed for the best efficiency, or even there is some interband transition, or what's the actually phenomena is happening over here for the best results. So that should be given over here, right? And then if I've looked on the graphical abstract, oh, nice. That looks nice, but one thing I'm afraid that I could see in the graphical abstract antimicrobial results. But even in abstract, I couldn't see even a single word about that antimicrobial activity or its results. So, and even I couldn't see even in the title that is not focusing on antimicrobial aspects. So you have to be careful about that, the title and even the graphical abstract, and right. So even in the keywords, I can see in the keyword there should be some percentage photocatalytic activity. That's I could see. That's absolutely fine. Methyl orange dye that has been used. So let's write 4 to 6 keywords, and even you can use BIOCL or AG.BIOCL. So that's the good thing to even use for as a keyword. So let's move on for the introduction. So introduction starts that looks reasonably good, which I can see that the first part should more focus on even the applications or the highlight or significance of the present study that is given. That's absolutely fine. The second part must be some of describing its mechanism. Then it's absolutely fine. So one suggestions I can give over here that even TiO2. So O2 mean this 2 should be in subscript. So that could just like which is written over here and over here. So I would always suggest that don't use the sentence with straight away with the abbreviation. The TiO2 would be good enough. Mean there should be the addition of the before TiO2, and then it's good. So let's move on. And if so, I'm just having an aerial view of this first manuscript that is given by one of my students. So now over here again you can see that you can see that AG is a silver. So first it should be defined somewhere above wherever first time it's been written AG, and then it should also be started with addition of the. And then I presume this is the last paragraph of the introduction, which should be more about this research work. So yes, that is the synthesis of AgBiocel nanoparticle. And if you see, can you observe over here that at the title there was a nanostructure, and over here this is a nanoparticle. So now you have to decide, or once you complete your research work, then you have to be very confident that either this is a nanostructures or even this is a nanoparticle. So there is a hell of difference between nanoparticle and nanostructures. So nanostructures could be of any uh, shape, but when we are very clear and focused about the nanoparticle, that has to be very specific. So we'll see the SEM image how it looks like. Even if you can see that over here, it should be again, this is sentences started with abbreviation, so that's not a good thing. And even I could not see, there were some of the characterization was involved, XRD, PL, SEM, that should be mean over here. It should also be added in the last paragraph that we will synthesize the sample, say that Ag, dop, BiOCl, and the doping concentration. That's very good. It's written 1%, 3%, 5%, and 7%. And the synthesized sample will be characterized by the technique known as PL, SEM, this, right? And even if there is antimicrobial part or results is also included, so here that should also be spelled out over here. That's very, very important, right? So that this article is deficient with that aspect as well. Now, let's move on to the materials and methods. You can see material title is materials and methods, and then the next is section subpart, that is 2.1, that is chemical. In my opinion, materials is of course chemical. So 2.1, here it should be the subheading, that is materials. Or if you are writing the materials in bracket, you can write the chemical, or even in materials, then you can write another subheading, that is the chemical, if you have two or the more subheading. Otherwise, straight away writing the material, you can actually mentions the chemicals over here, right? And over here, which I can see, the deficiency in that materials is that we are that there is no subscript, like for example AgNO3. This 3 is not in subscript. Even over here this 2 is not in subscript, these three. So that should be given importance about it, right? So that is very, very important. And then, so even when we are using the methodology, now you can see over here, yes. If I write the chemicals over here mean materials, that is 2.1, and I can write the 2.2, that is methods instead of methodology. That's the good thing to move on, right? But even sometimes that's okay if we are writing the methodology. But if you can avoid that, that's the good thing. Now, this is something amazing which I can see over here. The sentence is started with number 40 milliliter of the distilled water. So please do not start the sentence with number, right? Just you can structure a sentence in a way that the number should not be at the start of any sentence. And even I can see that 80 degrees Celsius in bracket, there should be just like the 80 degrees C over here in bracket. If you can write that, could have a more good impact over there, right? So let's move on. Now look at this. Is as we have explained in the last session, that the caption should be self-explanatory. So, which I presume that the figure one is basically the schematic of the various steps involved in co-precipitation techniques for synthesis of AgDO BiOCl. So that should be the caption of that figure one, right? And another very interesting thing is that there is a figure one, but I cannot see even figure complete word or fig one. I could not see over here that whether it has been called in the text. So figure one is missing, and it's not been called in the text. So let's have a look at the next. That is instrumental analysis. So we are using, I think the first section is being used as an XRD. So X-ray diffraction spectroscopy. X-ray diffraction. Here I would suggest that we should write XRD, and then next onward we should use XRD. And over here, this is K alpha. Alpha should be in subscript, and then another very interesting thing that I would not prefer this X over here, but rather this should be a symbol uh, that should be used if yes, this is a symbol I think. So I would say that we should replace this X with because that is indicating the times. So, so when we are saying that this is at least 100,000 times. So another suggestion is that we should not write. So it should be like 100,000 times that magnification is, right? So that's very important. So now you can see over here that even the unit that is the 200 nanometer, there is no space, but afterwards to 900 nanometers, so there is a space. So use the same, but I would prefer that after the numeric values. So let's have a space over here, the nanometer, right? And even I can see the FTIR that has not been called before. So it should be first, it should be spells completely and then use the abbreviations like FTIR. Okay. And surprisingly, if I'm not wrong, oh no, that's fine. Figure 2 has been called in the text. That's absolutely fine. So, and another good suggestion is if you see, I think that should be on the superscript. And over here, we should not write 10 to the power 6 and even in meter cube. So it should be that the 6 mean we should avoid this sign and then the 6 should be in superscript. That would have a good impact. And over here, you can see that this is not properly addressed over here. And the same mistake we're doing over here. So that should have a symmetry. So, and over here, you see that the Weierstrass formula that is, so that formula must have some reference. And even another surprisingly, this front wants that Divisor formula when once it's been used, then the student has actually calculated crystallite size, so that is 44 nanometer. So this crystalline size must have some error, so that should be indicated with plus minus something. And even here this should not be the reference. If the student is assuming that this reference is for this formula, so that should be written over here and it should not be written over here at the end, because I presume that even there is a mistake that yeah, the sentence should not be started with a number, but even then, if it is written that 44 nanometer, I think this is the real result of this one. That should be compared. If that result is compared with the literature somewhere, so that sentence may be rephrased. Otherwise, this reference, if that is presumed that is for reference for this equation, is that should be at somewhere on the top of the formula. And then let's move on. When we are using over here, if you see the XRD pattern of BIOCL and AG of BIOCL 7%. I presume that 7% is an optimal sample. So in that scenario, I would suggest that don't use XRD pattern or analysis at the start, but that should be given before the photocatalytic activity. You can actually add that XRD there. Reason because of that, either you have to use all. In principally, XRD should be at the start, but if you have XRD patterns of all the samples, if you are interested to include that. Otherwise, XRD should not be at the very first place. You can start with UV visible, and then even you can go for PL, and then you can use for SCM and other things. And then let's move on to the SCM and EDX analysis. Again, I would suggest these X should be replaced with symbol X, and then that looks reasonably good. So over here, I can see there are the figure number 3 and the 4, both of them, they are the SCM image. I would say that there should be the one SCM figure, A, B, C, D, instead of A, B, A, B. So for, and even I presume that these figure number 3, if that is AB is written over there, so caption must contains A, what the A is and what's the B is. And because I presume that A is at higher resolution, and B is at lower resolutions. So I can see from the scale that this is zero point 0.2 microns, this is 5 microns, but that should be spelled out in the caption. Or I would say use this SCM image and put this A figure in the inset of the this figure B, and then that would serve the purpose. So even in figure number 4, we are writing like and A and B should be explained in the caption of the figure number 4. And then similarly, figure 5, that's fine. And then let me go through the section 3.3. UV visible spectrometer. You can see it looks very odd that we are using SP-IUV and UOG double beam UV visible spectrometer. A double beam UV visible spectrometer was applied. So avoid repetition. So you can phrase a sentence in a way that there should not be some repetitions. So reasonably good afterwards, then it's absolutely fine. Again, there is a suggestion is that equation 2 must have some reference over here when we are writing the formula, and even here we are representing E A. I presume that here it should be the EG, so we should actually explain that EG. And over here, and I could not see the NE in the formula, why it's been there. So so you have to be careful about it. So whatever the symbol you are using in the equation, that should be actually used over here. So then we are using A and B, UV visible. Now you can use the this should not be bold, otherwise all the caption should be bold, and over here you can see fake, so it's repeated 2 times, then that doesn't look nice, so you have to change it accordingly. There should be some symmetry. And even I would say that writing the model number instead of writing this, I think that is written for the model number or the instrument name, so that may be in somewhere in supplementary data you can add that, because that doesn't look nice over here. And then if we move on, I can see one of the sentence that the new defects peak produced by doping significantly affects the frequency of electron hole pair recombination. So if there is a new peaks, which I couldn't see it, but even if there is some, if you are calling that this is a new peak, so that should be actually highlighted in the graph as well. So that could give you a good impact. And then Again, we should not start with abbreviation. Then this is, I presume, nanoparticle. But at the start, there was a nanostructure. Again, I just want to repeat it, right? So there should be the symmetry. And over here, you can see that is per centimeter. So this -1 should be in superscript. So that's perfectly fine. And then when we are using photocatalytic activity, so again, this is a formula that must have some reference. And over here, I can see there are the two dots in full stop. So we should avoid that. I know this is a type of mistake, but again, you have to be very careful about it as long as you can. So I can see if we move on, oh, nice. So figures are starting from E, F. Oh, that is not good thing too. E, F, C, D. So it means A, B is missing. So this mistake sometimes the students do it. So let's see the caption. So it means caption is indicating that there must be some A, B, right? A, B, C, yes. But in figure that's missing. So that should not be like that, right? So let's move on. And then the section 3.7, that is photocatalytic mechanism. That's absolutely fine. And over here, I think there is some typo mistake. So then again, I would say that if this equation is particularly related with the present studies, are if that is from the literature, so we that must contain some reference. Otherwise, it's fine. And then you can see another very interesting thing which I can see over here. The mechanism of the photocatalytic degradation is depicted in figure 6, right? But the mechanism, this mechanism is called, contains the caption that is figure 10. But in the text, it is called as figure number 6. So that's the not good thing to move. I think that is because of the typo, that it may be copied from the thesis. So because of that mistakes, that actions, this makes mistakes exist, right? And then you are using scavenger analysis, figure 11, then it's fine. And then cyclic test, that is reasonably good. So the caption, and another very interesting things you can see over here. Afterwards, in my opinion, there should not be this antimicrobial activities that should be there, as because the title is not depicting any aspect of the antimicrobial, but if that exists, so that must have some more detailed analysis should also be included. Otherwise, there is no need to add that antimicrobial aspect, and that should also be removed from the graphical abstract. And then if you see the conclusion, so the conclusion is somehow the summary actually. So again, if you are writing that in this work, a preparation approach was used to create this, so you should say that you have successfully synthesized the sample using this concentration, and then what are the achievement or the conclusion. If you go my previous session of the conclusion, what the conclusion should be, that would be helpful for writing the effective conclusion. Even you can see the sentence is started with abbreviation. So avoid using that, and even you can see some of the grammatical mistake typo. So that should not be there, and even you can see in the conclusion, I could not see any even single word related to the antimicrobial activity. So it means that antimicrobial activity is somehow an additional results which is given in that manuscript. And then at the end, let's have a brief look on the references. I can see there is a page, start page is there in the first reference, and end is missing, but in all rest I can see there is page number started and that is there. But of course here again it's missing. So there should be some symmetry about whatever it is. That normally gives you a good impact. But if you are sending your manuscript for a journal which is limited for the 3 pages, so of course 15 to 20 references, that's fine. But as long as this is full length paper and there is no limitations of the word or pages, I would suggest that you must write at least 25 to 30 references. That normally that looks sounds well. Another thing which I can see over here, quite interestingly, that in 3.9 section I can see only the B is written on this figure, you can see, and the caption there is no A, so it means again this. So this is the first look I have presented, that how your manuscript is evaluated by your supervisor, or even once you submit it to the journal, even the editor can do it, right? For example, if I move for control F, that is table, you can see the table displays the elements weight and atomic percentage, that is, and even I would try to search the table. So table is not there, but even the word table is given, so it means this is a mistake. Even similarly over here you can actually say fig 2, say, if that is there, so that would be shown over here. If it's not, so using that you can actually check, double check your manuscript, because these are the hints or the tips before submitting your to any of the journal. So these tips would be very helpful for evaluating your manuscript. I think it's enough for today's sessions. Thank you very much for watching and for your patience. If you have any kind of the questions, you can share your feedback. Then we can accordingly modify the PPT, or we can actually address that aspect in the next session. Thank you very much.